So you have 21 problems, and the first one's just the video. But for problems 2 through 7, so where it's just compound interest, or different times of the year. So semi-annually would be twice a year, quarterly would be 4 times a year, weekly would be 52 times a year, and daily would be 365 times a year, and then monthly would be a compounding every month or 12 times a year. And that is located, I'm going to give you the timestamp here, on your video. And let me just mute this. And I have it written here as 6 minutes, 53 seconds in. Is where he talks about, starts talking about the compound interest and application formula. So I'm going to go there so you can see what that looks like. About there. And that right there, let me just get him to move his mouse, this is the formula for compound interest. And he kind of does a nice lead in to this formula. He talks about why compound interest is better than simple interest, and he builds upon, how we got this equation. But this is how it's broken down. So you have A on the left here is the amount that is sort of like your goal, like the amount you want in your account. And the P is the principal, just like before. It's the amount that you need to deposit in the account, or you have deposited into account yourself. That was P. And then in parentheses, you have 1 plus the interest rate. The interest rate needs to be a decimal. So if you're given like 5%, that would be 0.05 for R. And then N would be the number of times a year that something's compounded. So I was kind of walking through those questions before, saying how semi-annually is twice a year, weekly is 52 times a year, daily would be 365 times a year. Okay, so that's where that N is. That's where that goes. And then we have another itty bitty N here. This is a power. So this whole, this thing in parentheses is to the power N times T. And N is the same thing, number of times that the money is compounded a year. And then T is how many years. So if they say it's 5 years compounded, then it would be, N would be, whatever, 52 if it's weekly times 5. Okay, so that will help you with questions 1 through 7, where you're figuring out, you're solving for A. You're given P, R, N, and T, and you're solving for A for questions on your homework 1 through 7. Now, question 8's a little bit different. That's going to be compounded continuously. So I have that highlighted for you. 8 and 9 are compounded interest continuously. And that's going to be a different formula. And I like how the video introduces the concept. And that is going to be right here. Compounded continuously. The concept is at 10 minutes and 48 seconds in the video. And then he goes into the formula and an example 14 minutes and 21 seconds in. And I'm hoping that I'm going through this breakdown, time stamping for you. Hopefully it'll make things go quicker for you when you want to look for help for your homework problems. Okay, so we're going to go to that. We're 10 minutes and 48 seconds in, so it's about right there. Okay, so he talks about, what if we were to compound continuously instead of like several times a year? What if it was like every minute, every second, just like continuously compounding interest over and over and over every millisecond, all the time is what he means. So that would be like making n compounding infinite times. And he goes through a really nice explanation if you want to follow through the concept. And then after that, he talks about, like I was mentioning, at 14 minutes and 21 seconds, he actually gets to the actual formula. And try to get him to move his mouse here. So there's the formula for interest that's compounding all the time, so continuously. So you have P dollars, which is your principal. That's what you're depositing into your account. So that goes here under P. And then you've got your annual interest rate that they have to give you, which is like maybe, 2% or whatever it is. That goes in R, but that would be a decimal. So if you're given 2%, it would be 0.02. If you're given 2.5%, it would be 0.025. Remember, you have to turn your percentage into a decimal. So whatever number they give you here, divided by 100, and that's your decimal number you put in for R. And then they tell you how many years you're going to be, this account will be compounding, and that will be T. So like 10 years, 1 year, 5 years. And then here you're solving for A. So, let's say I put in $10,000 and I'm continuously compounding a rate of 1.75%, and I do that for 5 years. How much money am I going to have at the end of the 5 years? And that would be your A that you're solving for. Okay, and so if anyone has any questions at any time, let me know. Let's see, there's just 2 of you here, so I could just maybe, let's see, turn you both on, or, oh, there's a chat. Let's see. No. Okay. Here we go. Oh, yeah, there's Raymond. So I'll unmute you, Raymond, if you want to ask any questions, or you can unmute yourself. Okay, so that covers Q1 through Q9. Okay, and this one, Q10.
So it's just the formulas that we just need to plug in the formulas, right? Correctly?
Yeah, but if, right, yes, those formulas, exactly. And if you want to see, if you're curious to see how the formulas are developed and need a little more help with understanding this formula, he covers them well, really well.
Okay.
And if somehow that doesn't work for you, you can, of course, ask me for help, of course. And there's a tutor too, so lots of resources. Okay, so the next one, it'd be, I think when you're trying to solve for the amount, how much do you get after 10 years, after 5 years, how much do you end up with in your account? Sure, that's the easy task. But I think what happened, and this probably happened to you in the last homework, is when you're trying to solve for principal, it starts to get a little complicated on the calculator. So those questions are questions 10 through 19. So 10 through 19. And it's basically the same thing over and over. It's just for different compounding, times. So this one would be semi-annually. This one's compounded quarterly. So that's 4 times a year. Monthly is 12 times a year. Weekly is 52 times a year. Daily is 365 times a year. So I'm going to actually, and then continuously, you just use that other formula with the E, okay? If it's continuously, you have to use it with an E. Oh, that would be here, yeah. So, but for 10 through 17, it's just the normal formula, and it's a larger formula. You use the same formula, but you're solving for a different variable. You're solving for principal, basically. And that starts at 9 minutes and 20 seconds into the video. So that's actually back over here. So that's the reason I wanted to put that in, to show you that you actually, if you skipped this before, make sure you go back to it to help you answer questions 10 through 17. Let me see. Thought I had it. Okay. So let me have him walk through this one for you. Go back a little bit. Okay. Oops. But I have to start over. So here is the question. So if you get a question like this, to save for college, parents of a newborn child invest $12,000. So that would be P, right? Because they're investing their own money. And they're investing in a mutual fund at 10% compounded quarterly. So the R is, the R is 10% or 0.1. And the N would be quarterly, which is N equals 4. And then, so the first part, he's just having you solve for A. So that's straightforward. You put in your P, 12,000, and your R of 0.1 in the R. And then the quarterly N goes into on the bottom here. And then you have 4 again, because that's N, just like over here, 4 times T. And T is quarterly, so that's 4. So then another 4 goes here. So you're going to have the 16th power up here. And then you solve, and then you figure it out for A. The question specifically asks for this particular one, it asks for T years, so you leave it as T. But in your homework problems, it's going to give you a time. So you'd put the 4 times 4. So you'd have to the 16th power. And you'd actually be able to solve this to find what A is. It's similar to what you did with your simple interest. Let's see. I have to change something here. Okay. Okay. Oh. Then switch over the participants here. Okay. All right, and so then we can find out, now they're going to change it to, oh, I'm sorry, this 4 was just for the quarterly, my mistake. So right here, so that this one we don't really know what the time is, so we leave it as T. Okay, I get that. I think I confused quarterly and time. So the 4 is just for the quarterly. It's not 4 years. We don't know what time is yet. Here they're telling us time is 18. So we put the 18 where the T is, years, right? And then you just put that in and calculate it. And then you solve for your A, which would be if you started with $12,000 and you were compounding 4 times a year at 10% interest, which by the way is really, I don't know how you'd find that. That's a great deal, actually. At the end of 18 years, when your child is ready to go to college, you're going to have $71,000 at the end of those 18 years. Okay, so that's how this goes. And then from there, he's going to ask a question of the reverse. What if you want to save up to for a certain amount of money? How much would you have to invest in the first place? So I'll have him go through that. That's where we are here. To save for college, parents invest $12,000 in a mutual fund at 10% compounded quarterly. Well, we covered that. But what if we wanted to make sure we had $48,000 for college? So how much would you need to invest? If if you know that you need $48,000 as your A, as your goal. So you're going to solve for P. Okay, so that goes into that other segment. Okay, so that's how you would do those problems from Q10 to Q17. And, just to make sure that, because I know this is probably the trickiest ones, actually, as far as you having to divide in your calculator. So what I'm going to do is I'm going to go over some more examples on just that particular area. So, okay, so let's go with this one here. From the current slide.
Just a question.
Yeah.
So if it's like semi, like when it says like semi, so it would just change it to 2, right?
Yeah.
Right?
Yes.
Okay. So you have to like read. Okay.
Yes, absolutely. Oh, whoops. I'm on the wrong thing here. Yes. Okay. So like, yes, exactly. So move this out of the way. Okay. Okay. So this is an example in which you need to deposit. They're asking for A. They're asking you to solve for I'm sorry, they're asking you for P because they're saying, how much would you need to deposit in an account? So how much money do you have to put in the account now? How much money, what is your principal? In order to have 6,000 in the future. Okay, so the goal is 6,000, so that's your A. That's how you read that. And in the account in 5 years. And then they give you 7% interest compounded monthly. Okay, so let's see.
What question is this?
This is just an example I'm giving in addition to everything else you have.
Okay.
This is just so we can walk through the calculator on how to do this ourselves. So, okay, so this is what we don't know what P is. How much would you need to deposit? So that means, what is P? That's what we have to solve for. That's your unknown. So we've got P over here. That's what I don't know. It says you're going to have 6,000 in the account in 5 years. So what is my 6,000? Which variable? We've got P, A, we've got N, we've got R, and we've got T, right? So let's fill those in. So what's my A?
6,000.
Yeah, yes, that's my goal. That's what I'm going to have in the future. And then they're telling me 5 years. I have to wait 5 years. So which one of these letters is 5 years? N, R, or T?
The N?
So the N is compounding. The N has to do. So the T is 5 years, yeah, 5 years. And then N is the compounded, this is compounded monthly. When you see this, this means N. So compounded monthly means how many times a year?
Oh, 12?
Yes, that's right. And then finally, we've got R, which is right here, 7%. And make sure you put that as a decimal, right? So you have to change 7% to a decimal. So I take 7 and I just move it over to the left 2 places.
The semi-annually, that just means 2, right? Because the annually is kind of throwing me off. Or is it just?
Yes, so annually would be 1 and semi-annually would be 2.
So it is 3.
What would be 3?
I was just like looking at one of the questions that I have, like going along with you, and it says interest compounded semi-annually. So I was like, isn't that just, wouldn't the end just be 2?
Yes, that's right. Semi-annually means twice a year.
Okay.
2 times a year. So N would be 2 in that case.
Cool.
Okay, let's see, what was I doing? Okay, so we're just gonna fill, okay, so we're just gonna go ahead and fill this in now. Oh, there's Brooks, yay! So we're gonna fill this in now here. Oops. Okay, so this is a compounding interest formula. It's not compounded continuously, it's compounded every once in a while. So you use this formula, and we already talked about what these letters mean from the problem statement. The A is how much what your goal is, and they tell you you want to have $6,000 at the end of all this, so that's where the 6,000 goes. And the P is they're asking you how much would you need to deposit. So they're asking you what principal do you need to put in at the beginning. And we don't know that. That's the unknown. So we skip that. And we can put in our R, our N, and our T. Actually, you could put our T in first because that's 5 years. But they're putting in then R in first instead. And that's the 7% interest. And in decimal form, remember, 7% is 0.07. You move the decimal place to the left 2 places. So that's why we have R here. And then our N is 12 because it says that this account compounds 12 times a year, compounds monthly. So that's 12 times a year. And then finally, 5 years is how long we're going to keep the money in the account. Okay, so how much principal do we need to invest? Well, here's where we're going to fill in everything we know and solve for what we don't know, okay? And you can do this. You can put in all the numbers and then divide. What they're showing how you're trying to get P by itself. So to get P by itself, you have to get rid of this thing here next to the P. And so you have to divide. Since it's P times that quantity, you can divide by that quantity, and that gets rid of it. It reduces to 1. So you have P times 1, which is just P. And then you have A divided by that quantity. So it's a little more tricky on your calculator to do this. But now that we have this form, so actually you could just write down this form. That might be another idea, rather than have to go through it every time. But if you want to solve for P, then this is a formula you would use. And they're just showing you how we got to it. So if I fill in all the numbers there, and I would recommend that you do this, follow this along on your calculator. So I'm going to have 6,000 for my A, and then I have in parentheses on the bottom, so divide by 1 plus 0.07, divide by 12. I'll do the 12 times 5 power, which is 60. And I'm going to put that on my calculator just like this. So go ahead and plug it into your calculator. And I'll also do it along on this screen calculator, and hopefully you can see it. If you can't see my calculator, let me know. But I'm going to put in, so I'm going to have 6,000, right? And then I'm going to divide, and I got to make sure I put parentheses on the bottom here. And I have 1 plus, and I have 0.07 divided by 12, close parentheses, and I have a little caret, which is right here next to, on the right of my keyboard. And then I'm going to have 12 times 5. Now I know 12 times 5 is 60, so I'm just, but you may not always know how to, let's say this were every day, 365 times a year times 5. Then I'd want to have the calculator do that for me. So I'll put that whole thing in parentheses. You must put this part in parentheses. So 12 times 5, and parentheses, okay? So that's what I have. So then in order to have 6,000 in the account in 5 years, I would have had to put in $4,232.43. Okay, so I'll see if you guys have any questions before I go on to the next problem, to the next example. And like I said, this should help you with your homework questions 10 through 17. And this is being recorded, and I will also put the PowerPoint up for you too. So you'll have the recording and the PowerPoint under the Chapter 5 area of MOER. The recording will be on Canvas. Let me know if you have any trouble with it. I'm running out of room on Canvas, so I'm having to resort to other types of recording methods. Let me know if you have any trouble accessing the recording. Okay, so then covered most questions. Let's see, where am I now? Okay, so that was for the case of compounding just normal, or compounding daily, weekly, monthly. Now, if you wanted to compound all the time, we talked earlier today about what formula to use, and then 18 and 19, use that formula, but solve again for principal. So we're going to go back to the PowerPoint. I'll show you an example of that. Let's see, that is going to be right there. Yes. So let's see, from current slide. Okay. So how much money would you need to invest to have $5,000 in 10 years, right? So the goal, so you're going to end up with 5,000 in 10 years. So that's the A. That's your amount. Think of A as like the accomplishment. Accomplishment will be $5,000 in 10 years. And the interest is 4.7 interest compounded continuously. The word continuously gives you a hint that you have to use this formula. Okay, so actually this is easier than the other one. You don't have so many, you don't have you don't have an addition and things. You just basically, you're multiplying and dividing everything. So same thing, if you want to get P by itself, right? Your goal is to have P, figure out how much do I need to put into my account so that I can accomplish $5,000 in 10 years. So you want to figure out what all the letters are. So the A is our 5,000. The P is unknown. That's what we're solving for. The R is the 0.47. When you move the decimal places 2 places to the left, that gives you 0.47. And then the T is 10 years. Okay. And the P is on the unknown. So let's fill in, let's go ahead and divide both sides by ERT. And that reduces the ERT to 1, because ERT over ERT is just 1, and P times 1 is just P. So you'll have P equals, and we're just flipping the sides and putting the P on the left and the other part on the right. So have P, our principal, equals A over E to the RT. And then just fill in what we know. We have 5,000 for A. Our R is 0.47, I should say, times 10. So that changes that to 0.47, because that'll move it decimal place to the right. Okay, so now we're going to put this into, go ahead and put this into your calculator. Make sure you know where E is and how to figure out how to work with that. And this is what it would look like in your calculator. So you have a 5,000 here divided by E to the caret. And again, put in parentheses this little multiplication here, this 0.047 times 10. Make sure you put that in parentheses. and see if you can get the same number. Okay, so I'll do it along with you. Clear. So I have my 5,000. I'm dividing, and I put parentheses. Very important, those parentheses. And then I find my E. So on this calculator, it's this yellow, right? The same button as the white LN. You see the still teeny tiny yellow E to the X. So I press second, and I press this, gives me E, and I have 0.047 times 10, and I need to have parentheses in twice. I guess I didn't really need the outer parentheses, but since I already started, I need to make sure I have a match. Okay, and then I press enter, and it's simple as that. So what is that telling me? That tells me that if I want 5,000 in my account in 10 years, I have to put in $3,125 and a penny to get there. Okay, and that's if it pays 4.7%, which is, I never hear of that. These must be old questions when we had higher interest rates.
Oh, what did you do after the E? I'm like having difficulties on my.
So the E, there's a little caret, so I raise it to this power here with this caret. That's called a caret. You put E and then you put power, 0.047 times 10. And if you want, remember how we were using the computer calculator last week?
Second E.
We can use that too. So I can show you how to do that on that as well, just to show that in case you don't have the TI-83. I did send everybody a link to download this actually for free, so you can download this for free, this exact one. Or you can use your computer calculator if you have a Windows machine. Just make sure that it's not standard. It's got to be scientific right here, scientific. And then that way you can use E. See, there's an E there. So again, here would be, what did we have? 5,000? See, 5,000. And we're dividing, and it's compounding continuously. So you have 5,000 divided by E to, and I use this thing on this calculator to raise the E to the RT. So I put R in parentheses and T. My R was 0.047 times 10 years, and my parentheses, and then there we go, same answer. So you can see all three ways here. Yeah, okay. So I'll stop and see if you guys have any questions. Otherwise, I'll move on to the next one.
So that was the second E, and then you just clicked on the caret. That's all.
Yeah, I have second, and then if you're talking about the TI-83, yes, I press the second button. So the second's in yellow, so that way I can get to the little yellow symbol.
For some reason, it's not letting me do the caret. I got the E part, just not the caret part.
And then you don't press center. You just simply press the this button here.
Oh, that's so weird. For some reason, it's like making it like go up.
Oh. Huh. Are you accidentally pressing second and then this? Maybe that's, no, that wouldn't work. That
No,
wouldn't, that would give you
regular caret. It's above the division sign. And I just.
Yeah, you're right about that. And you have this exact same calculator, the software?
Yeah, I have the Texas Instrument, the TI-84.
Oh, well, that is weird. Maybe some setting is affecting that. I'm trying to think of another way you can do that. No, that means power. Let's see. Math.
In the settings, because this is a newer calculator.
Yeah, it should, because I was using my TI-84 CE last night, and it was
But like, it wants me to put like a number or something in there every time I like.
Okay, well, when we're done with this, maybe I'll have you in private kind of show me
Okay.
your, yeah, I don't know if you could, actually, I'm not sure how you can show me that unless we do like a, yeah, I guess if you have a camera, you could show me. Actually, yeah, you have a camera, right? So
Yeah.
if you turn on your camera, I could see it. I'll send you a request to start your video. Boy, this is gonna be hard to see. Okay, yes, okay. Oh, it's okay. Is that a little up arrow?
It's just like a box, like a square
Okay,
box.
go ahead and type. Yeah, that's actually you want that. So put in parentheses. Just type parenthesis, open parenthesis, and then 0.047.
Like that?
Mm-hmm. That's a parenthesis? It looks like a parenthesis. 0.047.
Okay.
And then times 10.
0.
Yeah, I think you're good.
Yeah. I don't know. It just looked different. I didn't want to like mess up anything.
I'll show you just okay. If I just did it, if I had just done it all by itself on my screen here, if I do second E like this, oh yeah, it does look different than yours. Okay, it's because yours is the more advanced one. Okay, so you're fine. So put in 0.047 times 10, close the parentheses, and I'll just see if you can get that correct answer.
0.04710.
Times 10. Don't forget your times. Times.
Close it and times 10.
Yeah, times 10, and then close your parenthesis.
Okay, and then close it.
Yeah.
I did not get that.
Okay. You know what I'm going to do? I'm going to start over, and we're going to do it together at the same time. Sometimes it's easier to do it that way. So let's go ahead and clear everything off, and we'll just redo it. Okay. So I'm going to put in. Let's do it together. So put in 5,000 first. Got that?
Yeah.
And then press your division sign.
Got it.
And then you press your second and E, and yours is going to look different. Yeah.
Yeah.
And then put in your parentheses. So you have, type in your parentheses, just one. Just put in your parentheses there. Okay. And then right after your parentheses, put in 0.047. Oops. 0.047 like that. Do you have that?
Yeah, 0.0.
And then put your time. So you should have like a little asterisk or something. Yep. And then right here on my screen, you see I'm closing the parenthesis, right?
Yeah.
So does it look like that?
Yeah.
Okay, now press enter.
Okay, yeah, I got that.
Okay. Yay! Okay. So it's the same, it's just a little bit different format. Great. And like I was telling everybody too, if you don't have access to the calculator, which we actually do, but if you don't like it or are used to something else, you could use the one on your computer as well. Okay. All right. So how you doing, Brooks? Brooks, I know you kind of came in, or Unique. You kind of came in.
Following along.
Yeah. Okay. So is it okay if I go on then?
Yes.
Okay. Great. All right. So let's see. What have we done? We did all these. And so we're just 20 and 21. Okay. So for 20, it's going to be really a lot like a problem I'm going to run through here. Yeah. Okay. Oops. Yeah, this one. Okay, so your question number 20 will be similar to this. You're just basically doing the same thing over and over, finding your value of your investments. You find A at the end of 4 years using annually, quarterly, weekly, daily, and continuously. So the only difference is the same formula, but the only difference is the N value changes. So I'll show you that. So you see, use this formula. It's not compounding continuously, so you just use this formula right here for the first 1, 2, 3, 4. And then your N value will change. You'll go from once a year, which is annually, to quarterly, which is twice a year. If it were semi-annually, that'd be twice a year. Quarterly is 4 times a year. Weekly would be 52 times a year, and daily is 365 times a year. So the N would change. So we've invested, it's saying you have invested $44,300. So that's your P. And an annual interest rate of 9%. So that's my 0.09. And we want to find what A is at the end of 4 years. So that's our unknown. So we just plug it in, same formula over and over, different ends. So this is everything in the formula, and we just have our different ends. So in this case here for annually, N is 1. So that one's really easy to calculate. And then for quarterly, we use the same thing. We put in all these numbers, and we just make sure that N is 4.
I'm sorry, why did you say N for varies?
Varies because we have annually, quarterly, weekly, daily, and continuously. So N is going to change.
Oh, yeah.
That's what that means. Yeah. And so here we filled in everything, and we put in N instead of 1, we have 4. So this is going to be the 16th power. So if we compound it quarterly, would you expect to have a little higher number or less money after 4 years?
Higher.
Yeah, it's going to be a little, because that's right. That's called the power of compound interest. It's going to be a little higher, right? You actually get a little more than 4% at the end of 4 years. So if you can go for compound interest when you want to earn money in an account, go for compound interest. The more times it compounds, the better. Weekly is 52, so that's even going to be a little bit more. Put in 52 here. Just be very conscious that this is 52 times 4 in your power. So make sure you put that parentheses. And that's going to be a little higher, so about $200 more. I see the biggest jump from annually to quarterly so far. And then this one is a jump too, but not as much. And then daily, if it were compounding every day, 365 times a year. Put that in for N. Multiply by 4 up here. And then that's even a smaller. It's only like not even $20 more, but it is still more. And then finally, if we're compounding continuously all the time, we got to change our formula, right? We can't use that one up there anymore. We have to use the one with the E in it. Continuously means use E, right? Make sure you change your formula, and it's actually a lot quicker to calculate. It's just your principal, 44,000 times 44,300 times E raised to that power 0.09 is the rate times 4 years. And that's going to give you, that's only like, it's not even $3 difference, but it is a little bit more each time. Okay, so that should help you with question number 20 on your MOER. I'll show you why. Because, get over there. Lost my place. Now I can't seem to find. There they are. Okay. Okay, this one. See how in your homework it's just like that? Annually, semi-annually, monthly, weekly, daily. Just remember, semi-annually means N equals 2. N equals 2 here. and then the continuously. So that PowerPoint example, if you get lost, that walks you through it. Okay, finally, we have this last one. Find the effective rate of an account that earns 7.4 compounded. So effective rate, and that's covered, and I'll show you where it's covered in the video. That is going to be right here, 18 minutes and 40 seconds into your video. So that's going to be right there.
I think there's something wrong with the audio if you're speaking.
Oh, is it not capturing? Can you not hear the video going?
No, I can't. I thought it was me at first, but I was like, wait.
Oh, okay.
Yeah,
I'm not sure why you couldn't hear the video.
Yeah.
Okay. Then I'll speak for him. Okay.
Okay.
So yeah. So the goal of this is to determine how good which account is better. Like if you have two different accounts.
Is that the formula for the?
Yeah, this is the formula to determine the effective interest rate. Basically, what is the interest rate of an account, right? So you have two of them. Depends on if you're compounding, a number of times per year. That would be this one. So if you're compounding several times a year, you would use this formula, which is R with a little e on the bottom equals, and in parentheses, you have 1 plus your interest rate that they give you divided by the number of times a year you're compounding. So like if it's semi-annually, it'd be 2 there. Then you put the same 2 as your power, and then you'd make that calculation here, and then subtract 1, okay? And that would give you the effective rate of interest for that account. If you had an account that says, well, I'm compounding continuously, then you'd use a different formula to calculate. You have a different formula. You'd have the effective rate, interest rate would equal to E, right? Because continuously means, when you see the word continuously, you need to use that exponential operator, E, that exponential function. So I have E to the R, and R is your interest rate that they give you for 4.7 would be 0.47, 0.047, I mean, and then minus 1. So then he just kind of goes into how to apply it. So maybe I can have you guys try this. Which is a better rate for your investment? 5% compounded weekly or 4.8% compounded continuously? So instead of having to go through, you figure out your principal and your amount and all this stuff, you can use that simple formula that we just did in the last slide, in the last slide, to figure out which is a better investment. Would I be better off 5% compounded weekly or 4.8% compounded continuously? And this kind of helps you decide which account to put your money in. So it does have real world value. Okay, so for the first one, it says compounded weekly. So you have to use that RE, right? 1 plus R over N to the N minus 1. So if you fill in those numbers, they tell you 5%. So that's where that 0.05 comes from, because that's where the R goes. And then it says weekly. So that's where the N goes, right? This is just plug and chug, right? Put this in your calculator and take it to the power of 52. And then subtract 1, okay? And if you can try that on your calculator, see if you get this number here. You should get about 0.051246, okay, which is, if you move the decimal places over to the right 2 places, that's about 5.12%, okay, for the first. So for a 5% compounded weekly account, you'll actually make a little over 5.1%. Okay, that seems pretty good. What if you had 4.8 compounded every single second of the day, continuously all the time? What would that? How would we calculate the effective rate from there? The actual rate you're getting, basically. Well, you have to use a different formula because it's continuously. So we discussed the two formulas. So this is the second formula, right? They have effective rate of interest. You have e to the r. This one's real easy, right? Just e to the 0.48 minus 1. So if you plug that into your calculator, okay, you have put in that second, e to get to the e, and then the caret, and then you have 0.048, like shown here, and then I subtract 1. So even if you're continuously every second compounding your interest, you're making interest on your interest on your interest, because it doesn't quite make up for the difference in the percent. So the percent still beats it in this case. Okay, let's see. Okay, you can see that, right? This was about 5.1% here on top. And if you move the decimal place over, that'll be 4.92%. So even though it's still compounded not every single second, because it's 5%, it does better. The compounded continuously can't quite make up the difference. So then I would choose the top one, 5% compounded weekly. Now we'll get a little more money. Does that make sense? But definitely, make sure you know how to do this on your calculator, right? So I'll follow along here for the top one, weekly. I have, oops, I need to clear this. My calculator just froze on me here. Let's reopen it. Okay, so I have parentheses, 1 plus 0.05 divided by 52, whoops. And parentheses. And then I take that to a power of 52, right? And then I subtract that whole thing minus 1. Okay, and that's what I have. It matches what he has in the video. And that's for the top case. So for the bottom case, on the bottom here, it's just, e to the r minus 1. So I have second e, and then I put in 0.048, which is the interest rate they give me. Okay, and finish my parentheses here. Make sure you end the parentheses here, and then subtract 1. And that should give you then the right answer. And this is not as good as a number as the first. So that's why the first one wins. Okay, so that covers everything for this chapter. We've gone through all the questions. Let me see if there's some more examples here. Yeah, if you want to try this one, same thing. They said, what's the effective rate of an account that earns 3.4 compounded annually, monthly, weekly, continuously? So we can see amongst these four, how much better it does. In this case, continuously, I'm going to guess that this is going to win, right? Because this hasn't changed, but this has changed. So if you're compounding all the time, starting at the original interest rate here, but you're compounding interest over interest over interest, then this will win in this case. So let's go through that annually. We have for the first three, annually, monthly, and weekly, you're going to use this formula and just plug it in. Your N is going to vary, but your R won't. So you have most everything plugged in, and you just kind of change your N's over and over. If you're good at programming or Excel, you could actually write a little Excel program and have it do it for you quickly. So this is a case where N equals 1. So you have that, you enter into your calculator, and I'll give you 0.034, which makes sense because it's only compounding one time a year, which is what the original rate is, what it does. If you did it monthly, that's 12 times a year. So you're going to have a little higher of interest rate. See that, just a little bit higher. Instead of 0.34, you'll have 0.345. So it's a little more. Weekly, 52 times a year. So it's going to be even higher by a little itty bitty bit more, 0.01% higher. And then finally, continuously, where we have to switch to a different formula. So we have this formula now, we have e to the r minus 1. So r is 0.034 minus 1, and then plug it in, and there you go. So that's going to be a little itty bitty bit higher. We had a 7 here, we have an 8 there, but it's almost the same. But still, continuously, just maybe it'll be in pennies, but this will give you just a touch more. Okay. Okay, so if you had different rates, then this may be a different story. But because you have the same rate and you have different compounding periods, then the period with the most compounding times will win. They'll give you the highest effective interest rate. Okay. All right, well, that's it for today's lesson. Like I said, this is only this section in 5.3, which we'll cover on Thursday. And then you have your project, which I'm going to have due next Wednesday. And we can have a meeting on that too. But let's see. Let me just check and see if anybody has any questions.